I was going to start this video with a bunch of gravity puns, but after careful consideration, I decided it would be better to leave them out.
Careful consideration. I bribed you with McDonald's.
I really considered my options though.
Anyways, Kenny was going to start this video with the gravity pun, but I made him drop those ideas.
A couple of months ago, we sent out a vote for the first mandatory video.
Newton's 3 laws of motion won the poll with 100% in favor. With 3 votes.
Hey, don't hate. Unanimity is unanimity.
Today we will be going over the 3 rules of motion. Did I say that right? Yeah, giving some examples.
And the part that I'm looking forward to the most is conducting some experiments on them.
So what are the Newton's laws of motions?
Put simply, the 3 laws of motion help us understand how objects behave when they're moving. Move.
No.
Okay.
No.
Yeah, moving. Standing still, or when any sort of force acts upon them. When they are moving, standing still, like that, and when any sort of force acts upon them, like that.
It's not coming.
Yes,
The first law is also commonly known as the law of inertia. It states that an object that isn't moving won't move. And a moving object keeps moving at a constant speed in a straight line unless acted on by an unbalanced force.
Wow, that's a lot of words. Now to do some research on this. Well, that was informative.
Indubitably.
The first experiment is pretty self-explanatory. An object at rest remains at rest, just like the ball did, until another ball rolled into it.
This demonstrates the final part of Rule 1, that an object in motion remains in motion unless acted upon by an unbalanced force.
Here, the ball was moving along, minding its own business, until it ran into the second ball and essentially stopped moving. The first ball is the uncertain force that acted upon the second ball and caused it to lose motion.
Very interesting, very informative.
The soccer ball shows us about phase 2 of the law of inertia.
As we could see in the first soccer ball clip, the ball rolled across the screen in a straight line, with relatively constant motion. This is because there was no uncontrolled force acting against the ball.
You may notice that it began to slow down towards the end though, and there was in fact a force acting against the ball. It's friction, but that's a topic for another day.
The last clip is pretty self-explanatory. An object in motion remains in motion unless acted upon by an unbalanced force, in this case, an aggressive soccer player.
I think that's enough for the first law of motion. On to the second.
The second law of motion states that when a force acts upon an object, it will accelerate, and that the greater the mass, the greater the force needed to make the object move.
Time to research. There was a guy watching us. I think we almost got in trouble there for a sec. We're just pushing it back and forth here. There's like an employee there collecting the carts, right, from the stands. And he's just sitting there and watching us. And I always felt very concerned when David hopped in the cart because it bent. Anyway.
So as we could see, the heavier the shopping cart got, the more we needed to push.
An empty shopping cart needs less force than a shopping cart full of human.
Then there's the car. That was heavy.
The bigger something is, the more oomph you'll need to get it moving.
Moving on now to the final law of motion. This one is probably the most confusing of all three, for him at least.
Yeah, it's true.
The third law of motion states that every action has an equal and opposite reaction.
This means that pushing on an object causes the object to push with equal force, but in an opposite direction.
Observe. Hopefully, with these newly acquired visual aids,
What?
we can make this law of motion a little bit easier to understand.
What? I think that the last clip best illustrates this law of motion.
The ball hits the floor and exerts force on the ground. The ground pushes back with an equal but opposite amount of force that helps the ball bounce back up.
The second clip makes this law visually easier to understand. Here, Jack is pulling on the rope to move the sled along, and the rope goes taut.
Why? Because the sled is pulling back with an equal amount of force. I'm pulling in one direction and the sled is pulling in the opposite direction with the same amount of force.
Then there's the first clip. Another easy to understand example. When you're standing, you're exerting force on the ground, and the ground is exerting the same amount of force back on you, keeping you up on the surface.
There you have it, folks, the 3 laws of motion. If you have any questions, we encourage you to do your own research or ask them down in the comments.
We'll answer them to the best of our ability there, but if we're going to be completely honest, doing your own research will probably have better results and give you less misinformation. We don't know what we're talking about.
So we've got 30 seconds to do a self-promotion and we'll make it quick. Anything past 30 seconds will be cut.
So we are on the road to reach 150 subscribers by the end of this year, as that is what we said we would do for a New Year's resolution.
And we are also getting punished for not reaching our goal for 2024. That is happening. We don't know when though. Probably around our channel's first birthday on June 11th.
Yes, our channel is getting a birthday.
No, it's not weird. It's just as weird as reaching a subscriber count in celebrating.
So if you don't mind subscribing to our channel, that'd be great.
This is our first of our... So as we could see, the heavier the shopping cart got... We have a shopping cart?
We'll do that later.
The more we needed to push.
An empty shopping cart needs less force than a shopping cart full of humans.
What are we doing in this experiment?
just trust me.
Okay. then there's